All right, Integrated 1, this is going to be your final lesson of the 2019-2020 school year. It helps you prepare for Tuesday's test. We're going to go through all the things that you need for coordinate proof here today. What I need for you to do is take the notes here that I'm giving. Go ahead and take them down on your own sheet of paper and then submit those on Google Classroom by midnight tonight. And you will get your final homework credit of the semester as well. The test is scheduled for Tuesday next week, so make sure that you go back and rewatch any of the videos that you need to in order to help you be successful with the test on Tuesday. All right, so here we go. So we're going to do all things necessary for the coordinate proof using these points. Point A is going to be -1, 4. Point B is going to be 1, 1. Point C is going to be -1, -2, and point D is going to be -3, 1. All right, so there are all the points. Let's go ahead and make a 4-quadrant graph. Let's plot those points, and then, like I said, go through the process of figuring out, is it a parallelogram, a rectangle, a rhombus, or a square? Okay, so again, get your graph set up nice and neatly. I'm going to just go to 5 in each direction. That's going to be plenty big enough. One, 2, 3, 4, 5. X-axis, Y-axis. If you need to, again, anytime during the video, go ahead and hit pause to catch up and then pick up from there. All right, so plot your points. You've got -1, 4, which would be there. That's point A, -1, 4. Point B is going to be 1, 1. There's point B at 1, 1. Point C is at -1, -2, which is here, -1, -2. And then point D is -3, 1. -3, 1 is point D. There is my shape. Go ahead and connect the dots, and let's determine what shape we have. Okay, so first thing that I'm going to do once I've got this all connected is I'm going to determine if it is a parallelogram. Now there are 3 ways, 3 things that you've got to do to prove that it is a parallelogram. Okay, number 1, you need slope of sides. So we're trying to determine, is this a parallelogram? We'll do that first. Okay, slope of sides. You can just count the slope. So let's start with, I'm going to start with side DA. I'm going to write down what the slope is. I go up 1, 2, 3 over 1, 2. So the slope of DA is 3 over 2. Okay, let's go for side AB. What is the slope of side AB? It's to go down 1, 2, 3 over 1, 2. So it is, if you go down 3 and over 2, that makes it -3 halves, down 3 over 2. Okay, I like to see you label that. We've been doing that in the other videos, what the slope is right next to the side. So the next side here is CB, so let's find the slope of CB. CB is to go up 1, 2, 3 over 1, 2, so it's 3 halves. Again, I'll write it on the shape here. And then let's do this for DC. DC is going to be to go down 3 over 2, that's -3 halves again. So, do we have the first part of parallelogram taken care of here? Are the opposite sides parallel? And the answer is yes, the opposite sides are parallel. So have we satisfied the first thing for parallelograms? Yes. Okay, opposite sides parallel. Okay, second thing for parallelograms would be that the opposite sides are congruent. So opposite sides congruent. And the way we do that is with distance formula. This takes some time. Okay, so let's start with side DA, and let's check its distance using distance formula. Okay, so the 2 points for DA are -3, 1 and negative 1 comma 4. Okay, do distance formula. Distance equals the square root of. You subtract the x's. x2 minus x1. Negative 1 minus negative 3. I've gone over distance formula many times these last couple of weeks. Go back and watch an old video if you can't remember how to do it. So again, you're going to do x2 minus x1 and square it. Add to it y2 minus y1 and square it. Okay, so minus minus here will turn to plus. So the distance is going to equal negative 1 plus 3 is 2. 2 squared is 4. So it will be the square root of 4 plus 4 minus 1 is 3. 3 squared is 9. The distance here is the square root of 13. Okay, so we've got side DA. Let's go now to its opposite side. Let's do side CB and see if they are congruent. So CB's side is negative 1 comma negative 2 and 1 comma 1 for the 2 points. Okay, so distance is going to equal, you're going to do x2, which is 1, subtract x1, which is negative 1, square it, add to it y2 minus y1, square it. Okay, so the distance is going to equal the big square root. Minus minus here turns to plus. 1 plus 1 is 2. 2 squared is 4. Minus minus turns to plus again. 1 plus 2 is 3. 3 squared is 9. So this is going to equal the square root of 13. So far, opposite sides are congruent. Now we need to do it for all 4 sides, though. And you need to do it for all 4 sides, even just for trying to figure out if it's a square or rhombus. That's always a possibility that we'll have to look at here in just a minute. Okay, let's do the next side. Let's do DC. So for DC, let's do that. Let's see, DC's points are negative 3 comma 1 for point D, and point C is negative 1 comma negative 2. Okay, so let's check that. x2 minus x1 squared. This is the big square root. So we're subtracting the x's, and then we'll add to it, we'll subtract the y's. Negative 2 minus 1 squared. So any minus minus will turn to plus. Negative 1 plus 3 is 2. 2 squared is 4. Negative 2 minus 1 is negative 3. Squared is 9. So this is going to be the square root of 13. Okay, we have opposite sides congruent for those 2 sides. Let's see if we have it for DC and its opposite side, which is AB. Okay, so let's do this again for side AB. Now AB's points are negative 1 comma 4 and 1 comma 1. So the distance is going to equal, again, you have to do this 4 times. You got to know what the distance of all the sides is. This takes some time, you guys. This is not a short problem by any stretch. Okay, so you do x2 minus x1, 1 minus negative 1. Let's make sure I wrote those numbers down right, which looks like I did. Squared. And then add to it 1 minus 4 squared. So the distance equals the square root of, minus minus turns to plus there. 1 plus 1 is 2. 2 squared is 4. 1 minus 4 is negative 3. Squared is 9. 4 plus 9 is 13. Again, we got square root of 13 for all the sides. So opposite sides are congruent, which meets the criteria for parallelogram. And it also might meet the criteria for rhombus or square. We'll come back to that in just a second. Now the last thing I want to check is the diagonals. So let's check the diagonals and see if they bisect. And the way you do that to check to see if the diagonals bisect each other is with midpoint. So you got to check the midpoint of the 2 diagonals. Well, I can draw in, I'm going to dot them in here in the picture, the 2 diagonals and see if they have the same midpoint. Now I can tell from this picture they're going to have the same midpoint, but let's just check it with the work. So negative 1 comma 4 and negative 1 comma negative 2. Okay, we're going to check that diagonal first. This is AC's diagonal. So we add the x's, negative 1 plus negative 1 divided by 2, comma, add the y's, divide by 2. So negative 1 plus negative 1 is negative 2, divided by 2 is again negative 1. 4 plus negative 2 is 2, 2 divided by 2 is 1. So that's the midpoint for AC. Let's do the same thing for the other diagonal, DB. So for DB, what are the 2 points for DB? You have negative 3, comma 1, and then you have 1, comma 1. Again, they should have the same midpoint if the diagonals bisect each other. So add the x's, negative 3 plus 1, divide by 2. Add the y's, 1 plus 1, divided by 2. So negative 3 plus 1 is negative 2. Negative 2 divided by 2 is negative 1. 1 plus 1 is 2, divided by 2 is 1. So negative 1, comma 1 is the other midpoint. Since they have the same midpoints, diagonals bisect. Now, by those three things, that the slope of the opposite sides were parallel, opposite sides were congruent, the diagonals bisect each other, we have proven it is a parallelogram. Okay, we're going to continue this problem, so go ahead and switch to the next video now, and we're going to investigate a little further to see if it is a rectangle, rhombus, or square.